Hello, my name is Sara Khan from group number 322 and my topic is vibrational spectra and nuclear magnetic resonance and electron paramagnetic resonance. So let's start. The frequencies, intensities, and polarizations of lines and bands in vibrational spectra give information on the structure of molecules. Vibrational spectrum. What is vibrational spectrum? The part of molecular spectrum in which the bands arise from quantized changes in the energy of mutual atomic vibration within the molecule. So, it is observed either on absorption in the infrared region. Infrared region we usually use here IR. Everywhere we will use IR for infrared region, or on scattering Raman spectra. Raman scattering is discovered in 1928. For a number of years, the vibrational spectra of biopolymers have been studied only as IR absorption spectra. IR, that is infrared region absorption spectra. So now come to theory of molecular vibrational spectra. It is based on possibility of studying separately the slow vibrations of atomic nuclei and fast electronic transitions, which is proved by the Born-Oppenheimer theorem. Okay, so the problem of frequencies of nuclear vibrations is classical. It is solved by taking direct account of molecular symmetry. So, the theories of intensities and polarizabilities in IR, that is infrared region, and Raman spectra hinges on the valence optical scheme according to which a particular dipole moment and polarizability can be assigned to each covalent bond. Okay, so the dipole moment of the molecule is the vector sum. The dipole moment of the molecule is the vector sum of dipole moments of bonds, and the polarizability of the molecule is the tensor sum of bond polarizabilities. Raman spectrum is determined by a corresponding change in polarizability. The IR, that is infrared region spectra of proteins and polypeptides, show the bands of amide group, that is peptide linkage, that is CONH. The investigation of low molecular weight amides, in particular methyl acetamide, and related compounds and theoretical calculations have led to deduction of the vibrational characteristics of amide group. So, now the spectra of solutions or in unoriented films do not give up information of vibration polarization. On the contrary, the polarization of vibrations is directly observed in investigations of proteins or polypeptides in an anisotropic media by means of polarized IR radiation, that is infrared region. Infrared dichromism, what is that? Is measured, which is characterized by the ratio of extinction coefficients measured for radiation with the direction of the electric vector of light wave being parallel and perpendicular to the chosen direction. Thus, IR spectra can be used for determination of secondary structure of a protein for the study of ionization of amino acid residues, and what is especially important for the study of kinetics of deuterium exchange. The IR spectroscopy of nucleic acids is less informative and is not practically employed. Okay, so now coming to my next topic, the other topic, which is nuclear magnetic resonance and electron paramagnetic resonance. So nuclear magnetic resonance is also called as NMR, and electron paramagnetic resonance is also called EPR. Okay, so NMR, nuclear magnetic resonance, is a physical phenomena in which nuclei in a strong constant magnetic field are distributed by a weak oscillating magnetic field and respond by producing an electromagnetic signal with a frequency characteristic of magnetic field at nucleus. Okay. So, the spectra of nuclear magnetic resonance and electron paramagnetic resonance are widely employed in biophysics. We place a particle with magnetic moment mu in a uniform magnetic field of strength h naught with frequency proportional to h naught. So here we will make a equation by this. So the equation is this, where p is the angular momentum of the particle. Electron paramagnetic resonance, this is EPR, or electron spin resonance. It is also known as electron spin resonance, ESR. Spectroscopy is a method for studying materials that have unpaired electrons. Okay, that have unpaired electrons. The basic concept of EPR are analogs to those of NMR. NMR is nuclear magnetic resonance. Okay. Okay, the basic concept of EPR are analogous to those of NMR, nuclear magnetic resonance, but the spins excited are those of electrons instead of atomic nuclei. Yeah, here the spins that are excited are electrons. They are not atomic nuclei, they are electrons. Okay. So, the study of chemical shifts and the hyperfine structure yields quantitative information on the arrangement and the interactions of atomic nuclei. Using high resolution instruments, one can resolve a multitude of overlapping proton resonance lines in protein. We can see these lines in protein, but by using high resolution instruments. Okay. Here the selective deuteration of the protein is also essential. It is most essential. Electron spin resonance